This time, I'm going to talk about how to predict interest rate with calibrated CIR model. In mathematical finance, the CIR model describes the evolution of interest rates. It is a type of one-factor model as it describes interest rate movements as driven by only one source of market risk. The model can be used to predict where interest rates will end up at the end of a given period of time. It outlines an interest rate's evolution as a factor composed of market risk, time, and equilibrium value. CIR model is similar with Vasicek model. This is the formula for Vasicek model. WT is a Wiener process under the risk-neutral framework modeling the random market risk factor. And B is long-term mean level. And A is speed of reversion. And the sigma is instantaneous volatility. Please keep in mind, once the Vasicek model is calibrated, all A, B, and sigma are constant. Now let's take a look at the CIR model. You can see the formula is very similar with Vasicek model. In CIR model, you can see there is the actual square root RT here after sigma. You can also consider as in CIR model, the volatility is related to the interest rate. That is, when the interest rate is high, the volatility of this item is also high. Comparing with Vasicek model, there is only a constant sigma here. So this item avoids the possibility of negative interest rates for all positive values of A and B. For the data used in this video, I went to this website and download monthly market rate of 3-month Treasury bill from May 1st, 2013 to May 1st, 2023. You can see the graph. It looks like this. And at the beginning, the interest rate is very low and it goes up. This is during the financial crisis, and then it dropped and keep it low until 2022 and jump up recently. You can also go to this website, download the same data. In my YouTube channel, I have another video called Parameter Calibration for CIR model. If you haven't watched that video, you are welcome to watch that video as well. In this video, I explained how can we calibrate CIR model already, so I will not go through the detail here. I just go through roughly about this calibration process. As you know, we have to decide A, B, and sigma for our calibration. We will go through all those processes to determine all those three parameters. If you want to know how the calibration process works, you can watch the video I mentioned above. Now let's go to the Excel spreadsheet to calibrate our CIR model. First, I download the market data of this US Treasury 3-month bill rate and put in this spreadsheet. You can see it starts from May 1st, 2013 and goes to May 1st, 2023. And if we draw a graph, the treasury rate looks like this. It's very similar to the graph we saw here on the website. And then we are going to minimize RSS by changing this discrete drift. So we'll go to change cell B3 is discrete drift and try to minimize B2. B2 is this one, RSS. Okay, let's solve it and keep solver solution. You can see we got speed reversion A, this value, and long-term mean, this value, and volatility, this value. You might have noticed the speed reversion is negative 0.0016 something. Why this speed of reversion A is negative? Mean reversion is a characteristic of many financial time series where the variable tends to fluctuate around a certain long-term average. In the CIR model, positive values of A indicate that the interest rate tends to move back towards the equilibrium level, B, over time. However, when A is negative, it means that the interest rate does not revert to any specific long-term mean, and instead it continues to drift away from its current level. If we check the market rate for the last 10 years, you can see the interest rate starts very low and goes up a little bit and drop again, and then start going up, and now it's higher than the previous high. You can see it doesn't show mean reverting, but this is for last 10 years. If we check from 1934, you can see the interest rate goes up and down, goes up and down, goes up and then down again, goes up. You can see this looks like mean reverting. If we go to the website, when we check the market rate for 3-month treasury bill, you can see the interest rate shows like this for the last 10 years. This doesn't show any mean reversion, but if we click max, this is from year 1934 to May of this year. You can see the interest rate goes up and down, goes up and down, and then reach peak here. This is around June of 1981, and it drops and then goes like this. And this interest rate shows a pattern of mean reversion. In this video, I only use this interest rate for last 10 years, and so the speed of reversion shows negative. You can also try to use longer time period and see if this speed of reversion becomes positive. I will upload this spreadsheet and also my Python program to my GitHub, and you can download them and try them by yourself. Now let's put all those calibrated parameters into our Python program. You can see I just copy and paste this speed of reversion here, and this volatility here, and long-term mean here, and then the starting interest rate. I used the interest rate as of May 1st, 2023, and I want to predict interest rate 1 year ahead. So it's 1 year period, and the step is 12. And then I have our CIR model here, and I'm going to run this Monte Carlo simulation. For the simulation path, I will use 50,000. In summary, I will use Monte Carlo simulation, and I will predict interest rate 1 year ahead, and with step size 1 month, that is 1/12 year. Use 50,000 simulation path. And for this market risk randomness, I'm going to use standard normally distributed with a mean of 0 and a standard deviation of 1.0. After this Monte Carlo simulation, we can get something output like this. Because the randomness, every time when you run the simulation, it will give you a little bit different results. Now let's go to Python and run our model. Okay, we will run our Monte Carlo simulation. You can see simulation path is 50,000, and the time interval is 1 month, and the output is looked like this. It started with the interest rate 5.14%, and the expected value for the interest rate is 5.155%. So it's very close to the current interest rate. And if we check, the lower 95% is 5.150%, and upper 95% is 5.160%. Of course, if you run it again, it might give you a little bit different results because this market risk randomness here, but it's very similar result. And we can see the interest rate 1 year ahead remain almost the same as current interest rate, but you can see it will go up a little bit. If you still remember, the initial data we are using is this for the last 10 years, and you can expect the interest rate will go up a little bit after 1 year. This is how you can calibrate CIR model and use it to predict interest rate. Please provide your comments and subscribe to my YouTube channel. Thank you for watching.